Hi everybody, welcome to another video in pre-calculus, section 6.3, trigonometry equation. So now we will solve trigonometry equation, namely sine of something equal to something else. So sine of u equal to a, cosine of u equal to a, and tangent of u equal to a. Cosecant and cotangent will be a reciprocal of this function, so we will do similar. Right, now we go back to the definition of trigonometric function. If our sine is equal to the y values, if we have a unit circle, then sine is equal to the y values, and cosine is equal to the x values. Notice that these two points have the same y values, therefore the same sine values. And this point and this point have the same x values. Right. So when we say sine equal to of something, then there will be two solutions across from the y-axis. When we say when cosine is equal to something, there will be two solutions in the unit circle across from the x-axis. Because of that, we have this solution. When we say sine equal to something, we have two solutions. First, it is the inverse of sine plus 2n pi. 2n pi meaning it go around the one revolution and get back to the same point, so coterminal angles. And then the other point is pi minus the sine inverse. So the relation between the sine inverse of a and pi minus sine inverse of a, those are called the supplementary relation. So where we have the pi minus, this is called the supplementary relation. When angles are supplementary, meaning that they add up to 180 degrees or pi. Right. So either we have the inverse or we have the supplement to that, meaning subtract from 180 or subtract it from pi. Next, if we have cosine of a, then we have the cosine inverse, and then plus 2n pi, meaning coterminal angles. Or we have this. And notice for cosine, we're going to have either one of these solutions, meaning one positive and one negative. So for the sine, for the cosine, we have the negative here, and of course the negative meaning opposite. And for tangent, it's easy. It's just the tangent inverse. But the period for tangent or cotangent, it's just a pi, right? So we will add n pi. So sine, cosine, the period, their periods are 2 pi. So that's why we have 2n pi. And tangent periods is a pi. That's why we just have an n. So I have this mnemonic here. Sine, we will have the sine inverse along with the supplement. Along with the supplement. Cosine, along with the inverse, we have the opposite. And tangent, along with the inverse, there's nothing else. There's nothing. It's just the inverse. But the period is just a pi, so we have n pi. Right? Of course, if we have in degrees, then we will use 180 instead of pi and 360 instead of 2 pi. Right, let's look at a solution. I'll find the solution on the solution for cosine of theta equal to square root of 2 over 2. Now it will be easy. For cosine, we will have equal to cosine inverse square root of 2 over 2. Now, this one did not specify anything, so I can pretty much use degrees. If I use degree, instead of 2n pi, I can use 360 degrees times n. Only this one I will use in degrees. Or for cosine, along with that, along with the cosine inverse, we will have the opposite. Cosine has the opposite. Cosine inverse of square root of 2 over 2 plus 360 degree times n. And then if we use degree mode, which I highly recommend when we use the inverse trig function, right, degree. So for inverse trigonometric function, use degree mode. Right, that gives us 45 degrees. So we have theta equal to 45 degrees plus 360 degrees times n, or theta equal to negative 45 degrees plus 360 degrees times n. So those are the solution. If we don't want to have the negative, we can also add 360 to this. And so if we don't want the negative here, just add 360 to it. Or we just use 315 instead. Right. This problem is not specifying if it is in degrees or radian. So I just give this one in degrees. Other problem we will have in radians. Right. Easy enough, right? So cosine is the cosine inverse, and the opposite for sine will be the sine inverse, and the supplement tangent, there's no thing. Right. We'll just keep working like that. Next we have 2 sine theta equal to square root of 2, but the solution now has to be between 0 and 2 pi. Not only that, we know it has to be in radian because the angle is in between 0 and 2 pi. Right, before that, let's solve for sine of theta. So we have 2 sine of theta equal to negative square root of 2, or sine of theta equal to negative square root of 2 over 2. Right? So trigonometry equation, need to get the trigonometric function equal to something. Then this is sine. So for sine we will have the sine inverse. Unlike the last problem, we use 360. This one we use radian mode. Use radian. So that will be 2n pi. And then for the sine, not only we have the inverse, there will be the supplement. Supplement to the sine inverse. Right, what is sine inverse of negative square root of 2 over 2? It is negative 45 degrees. Right, but this is in radian. Negative 45 degrees is negative pi over 4. Right, so that's one of them. The other one we have pi minus pi over 4. Wait, minus, and this sine inverse is not the negative. So it will be that plus 2n pi. Pi minus negative pi over 4, 1 and 1/4 is 5 over 4. Right? 1 pi and plus 1 pi over 4, 1 and 1/4 is 5/4. Right. Now, this problem, it is important that the solution is between 0 and 2 pi. ask you this. Let's say we have an interval between 0 and 2 pi, right? Yeah, so that is what we have. Now, whatever solution we have, negative pi over 4 plus 2n pi. Now focus on here, plus 2n pi in this problem, or n times 2 pi. In this problem, we have n times 2 pi, meaning the period is 2 pi. What does that mean is the solution will be, the difference between the consecutive solution is 2 pi. So, let me ask you this. If this is 2 pi, okay, and how many of this we can fit in here? By that I mean, if we start with negative pi over 4, right? And we'll go 2 pi from it. And this solution is inside that, right? But if we add 2 pi again, it will be outside. My point is, if the difference between the solution is n times 2 pi, meaning the length between the solution is 2 pi, you can only fit one of them into the length here, into the period. Here's the length is equal to 2 pi. The length of the interval is 2 pi. So we have 2 pi for the solution to be in there. And here we have 2n pi, meaning the period is equal to n times 2 pi, or we just say 2 pi. Ignore the n, we have 2 pi. That means the period is the same as the length, meaning if we want to fit the solution with different will be this much apart. So it can only have one of those values in here. If we have a solution here and we want to go a length of a period, it will be outside. Bottom line is, when we have this, we take the length, divide by the period, and that will give us how many values of n that we have. So we do the length, divide by the period. We have 1. What does that tell us? 1 here will mean 1 values for n. That means whatever we choose, only 1 values for n will work. So in that case, this will be easy now. At n equal to 0, theta equal to n equal to 0, we have negative pi over 4. At n equal to 1, theta equal to negative pi over 4 plus 2 pi, that's 7 pi over 4. And 7 pi over 4 is between 0 and 2 pi, so yes, so this one's good. Now over here, let's choose n to be 0. When n equal to 0, we have 5 pi over 4. And according to this, only 1 values for n will work, and we find 1 values for n, that works. So that's all we have. Only 1 values for n for each one of them. Right? So in this case, the solution set, we can say 5 pi over 4 and 7 pi over 4. Right. After a few more problems, you get the idea. Right, next, we have this example. Tangent equal to something. Once again, the solution is within the length of the interval of 2 pi. Now tangent equal to that, we will say theta minus pi over 3 equal to tangent inverse of square root of 3 plus, for tangent, there will be tangent inverse and nothing else, but the period is n pi plus n pi, right? Now what is tangent inverse of square root of 3? I still have to calculate in degree mode. That's 60 degrees, which is pi over 3, right? Because this one should be in radian. And then so we will add pi over 3 to the other side. So we have theta equal to pi over 3 plus tangent inverse of square root of 3. We did that would be 60 degrees, also pi over 3 plus n pi. Right, a pi over 3 plus a pi over 3 is 2 pi over 3 plus n pi. Now we look at this problem. Plus n pi, ignore the n. That means this from the period is equal to pi. Because n times something, just ignore the n, we have the period is a pi. Now, take the length divide by period. 2 pi divided by pi, we have 2, meaning we have 2 values for n. So we have 2 values for n. 2 values for n will work. Now, let's choose n equal to 0. Then theta equal to 2 pi over 3. Now let's choose n equal to 1. Put 1 here. 2 pi over 3 plus pi. 2 pi over 3 plus pi. 2 over 3 plus 1 is 5 over 3. Let's take a pi to it. So 5 pi over 3. Now 2 pi over 3 between 0 and 2 pi. So let's put this box around it. So this one's good. 5 pi over 3 also between 0 and 2 pi is good. And according to this, we have exactly 2 values for n. And we find 2 values for n. The solution works. And that's all we have. So we will do this just to see how many values of n do we have. Right. More of this. Sine of 2 theta equal to square of 3 over 2. Once again, the solution between 0 and 2 pi. Right. So, for sine, we have 2 theta equal to, for sine, we have the inverse. And then 2n pi. Or the sine, we also have the supplement. Right, now we solve it. What is inverse of sine of square root of 3 over 2? Right. Sine inverse of square root of 3 over 2. (60 degrees) or pi over 3. That of course also pi over 3. Now if we want to solve for theta, divide by 2 on both sides, or multiply by 1/2. Just multiply by 1/2 both sides. 1/2 times pi over 3 is pi over 6. Plus 1/2 times 2, 2 and 1/2 cancel out, plus n pi. Over here we have 2 theta equal to 1 minus 1/3. Yeah, pi minus, just ignore the pi. Do the number first. We have 2/3, and at the end stick the pi back to it. So when we do the math, combine the two rational, irrational numbers, just ignore the pi, add the numbers. 1 minus 1/3 is 2/3, and then stick the pi to it. And then we multiply everything by 1/2 to get back theta. So we have theta equal to 2 and 2 cancel out, we have pi over 3. And 2 and 2 cancel out, we have n pi. So we have pi over 3 and pi over 6. Right? Yet now the graph here. Next, how many values of n do we need? So the length equal to 2 pi. From 0 to 2 pi is the length is 2 pi. And the period in our problem is what? We have n pi and n pi, meaning that the period is without the n, it's just a pi, right? So when we look at the theta equal to something, we can see the period of the problem, and we have the period is a pi. And then when we divide them, 2 pi divided by pi, we have 1. We have 2, and that gives us 2 values for n. So 2 values for n will work. So let's choose n equal to 0. This is 1, n equal to 0, we have pi over 6, which is between 0 and 2 pi, so that's good. How about n equal to 1? Pi over 6 plus pi, 1 plus 1 over 6 is 7 over 6. Stick a pi to it. And this is still between 0 and 2 pi, so it is good. And there are 2 values for n, so that's all we have there. So you see, I find how many values of n do we have, and then when I choose 2 of them, when I found 2 of them, that's all we have. Now over here, same thing. At n equal to 0, we have pi over 3 between 0 and 2 pi. And at n equal to 1, theta equal to pi over 3 plus pi is 4 pi over 3. This is also between 0 and 2 pi. Yes, so that check. Right. Now in terms of the solution. Let's see. Let's say the solution has to be between 0 and 2 pi here, right? This is 1 period. The length of this is 1 period. So how many of this can we fit in there? We cannot fit 2 of them in here because this one doesn't include the boundary. Right. So whatever point we have inside, let's say that point, add in the period to it, we also have another point in here. But if we add one more time, it will be on the outside. So that's why we know there will be two of them will work inside, given the length is that much and the period is this much. How many of those can we fit inside? It will be exactly 2. And that's why we do this math. And we find there will be exactly 2 values, 2 solutions of them inside the 0 and 2 pi. If the period is this much. If the period is too much, we might not fit inside. If the period is too small, we might be able to fit a lot of more of them in here. But in this case, we know exactly 2 of them can be fit inside. So 2 of each. 2 values for n for each solution. Yeah, so it's simple enough. Next, let's do this one. Now we have secant. What happens when we have secant? So for secant, first of all, we will solve that secant by itself equal to 2. Now we write secant is 1 over cosine. And 2 we can say is 2 over 1, right? Of course, we can cross multiply and then solve it, or we're just going to flip both sides. So cosine of 2 theta equal to 1/2. Right. Now we have cosine. For cosine, the solution will be the argument or the angle equal to the cosine inverse plus 2n pi, or cosine along with the cosine inverse. We have the opposite. Sine is supplement, cosine is opposite, tangent. There's no thing for tangent. So cosine inverse and opposite. Right, cosine inverse of 1/2. This one's still in decrease mode. Yep. So cosine inverse 1/2, 60 degrees. Or pi over 3. Or we have negative pi over 3 plus 2n pi. Right. Now divide by 2 on both sides, or we multiply by 1/2 on both sides. 1/2 times pi over 3 is pi over 6 plus n pi. Over here, once again multiply by 1/2. Theta equal to negative pi over 6 plus n pi. Now, how many of those solutions do we have? This one, the length is equal to 2 pi. We have n pi and n pi, so the period is a pi. Divide them. So we have 2 values for n. That will work. Right, then just choose at n equal to 0. We have pi over 6 between 0 and 2 pi. Yep. At n equal to 1, theta equal to pi over 6 plus n equal to 1, so pi over 6 plus pi, 7 pi over 6, and that is also between 0 and 2 pi. Yep. Now here, when n equal to 0, theta equal to negative pi over 6. This is not between 0 and 2 pi, so that doesn't work because that's too small. Then we choose bigger value for n, theta equal to negative pi over 6 plus pi and pi over 6, or we have negative 1 over 6 plus 1, convert to fraction, 5 over 6. Stick a pi to it, and this is between 0 and 2 pi. Yep. Next, at n equal to 2, negative pi over 6 plus 2 pi plus 2, and we have 1.8, which is between 0 and 2, so we got 11 pi over 6, which is between 0 and 2 pi, so that one is good as well. So as you see, we will have two values for n that will work for each case. So 2 here and 2 there for solution. We have two values for n for each case. Right, nice enough, right? Right, next we have tangent of theta equal to negative 2. How many of those solutions that we have between 0 and 2 pi? Now we solve for that. So in this case, theta equal to tangent inverse of negative 2. For tangent, there will be no supplement, no opposite, just plus n pi. And once again, the length equal to 2 pi. The period is a pi. Meaning if we divide them, we have one values for n. If I can do the math, 2 pi divided by pi is 2. So 2 values for n. Right, so we choose 2 values for n. So this solution between 0 and 2 pi. What is 2 pi, by the way? Pi is 3.14, so 2 pi is about 6.28. So make sure the solution between 0 and 6.28, like what we have there. I mean, that way. Right, now tangent inverse. Wait, in radian, okay. Tangent inverse of negative 2. We have negative 1.1 something. Two decimal places. Right, so we have that. Now, of course, this do not have any nice values. We have this from the previous section. Those are the nice values for sine, cosine. Those are the nice values for tangent. By nice, I mean the angle is multiple of 30, 45, or 60, or a quadrant angle could be multiple of 90 degrees as well. Anyway, now we have two values for n. Let's choose some of them. How about n equal to 0? This one too small. How about n equal to 1? And we have that. Plus a pi. Right, 2.03. And that is between 0 and 2 pi. So yes, that's good. How about n equal to 2? Meaning we have this plus 2 pi. We have 5.7. Between 0 and 2 pi. Once again, 2 pi is 6.28. This is 5.18, so it's good. Right, so sine, cosine, and tangent, they have different type. Sine have the supplement period is 2 pi, plus 2n pi. Cosine has opposite, plus 2n pi. And tangent has nothing but plus n pi. Right, now find the solution from 0 to pi of this. So first we solve for tangent of 3x. Still square of 3. Add 1 to the other side and then divide. Right, for tangent there will be tangent inverse. But it's going to plus n pi instead of 2n pi for sine cosine. Right. So what is tangent inverse of 1 over square root of 3? If I want to have a nice values, it is better to give in degree mode, then we know exactly what the angle is. Tangent inverse of 1 over square root of 3. 30 degrees. Pi over 6 plus n pi. Right. And then we can divide by 3 on both sides. So give us x equal pi over 18 plus n pi over 3. Right, so how many of those values do we have? Now first we look at the problem. The length is still 2 pi. The period, ignore the n, we have pi over 3. And then we divide them. Multiply reciprocal. So we have 6 values for n. We work on this problem. Right, now we just need to do 6 of them. Right, at n equal to 0, the angle is pi over 18, which is between 0 and 2 pi, so it's good. Now n equal to 1, we have pi over 18 plus pi over 3, so we just need to do this. 1 over 18, right? Plus 1 over 3. So that's 7 over 18. Stick a pi to it. That also between 0 and 2 pi. And then we're going to have this. But this time we're going to add 2 of them when n equal to 2. And the fraction will be 13 over 8. And then n over 3. Oh, that's easy. It's 19 pi over 3. 19 pi over 8, sorry. Over 18. And then n equal to 4. Now notice this 1, 7, 13, 19. What do you think the next one will be? It's increased by 6 pi over 18, right? So 1, 7, 13, 19, we plus 6 to it. So the next one will be 25. And at n equal to 5, x equal to plus 6 will be 31 pi over 18. And if we choose n equal to 6, that will be 37 over 18, which is more than 2. So remember, we only have 6 values for n, and we have 6 values for n that will work. And that only 6 values for n will work. Right, so it's not that bad, right? Right, and now we go to a different type of problem, more types of trigonometry equation. Now we have 4 sine square minus 1 equal to 0. Now if we have just sine, so if we let u equal to sine of theta, so in this case u square equal to sine square, and the equation becomes for u square minus 1 equal to 0. Right, so we turn this into a quadratic equation. This should be easy, right? So u square, move the 1 over and divide by 4. Taking the square root on both sides. Don't forget, when we take the square root on both sides, there will be a plus or minus. Plus or minus 1/2. So we have u equal to 1/2 or u equal to negative 1/2. U equal to 1/2 and u equal to negative 1/2. When u equal to 1/2, u is sine theta. Right. Now we just need to solve both of them. Right. So for sine, what do we have for sine? Sine inverse. Either that or the supplement. Right, so we have theta equal to sine inverse of 1/2. That's 30 degrees, so pi over 6. Pi minus pi over 6 plus 2n pi. So pi over 6 plus 2n pi, or pi minus pi over 6 is 5 pi over 6 plus 2n pi. Right. Now solution is between 0 and 2 pi, so the length is 2 pi, the period is 2 pi, ignore the n, we have 2 pi, so length divided by the period. The length is 2 pi, the period is also 2 pi, so we only have one value for n. So here we just choose n equal to 0, we have pi over 6, n equal to 0, 5 pi over 6. Which is good. And when n equal to 0, we have 5 pi over 6. That's also good. So that is this part. The other part, we do the same thing. So theta equal to sine inverse of negative 1/2 plus 2n pi, or the supplement sine inverse negative 1/2 plus 2n pi. So integrate, yep. Sine inverse of negative 1/2 is negative 30 degrees, or negative pi over 6. Or the supplement so we have negative pi over 6 plus 2n pi, or 1 minus 1 over 6, that 1 plus 1 over 6, or 7 over 6, and we stick a pi to it. Right, now let's choose some value for n. Here we choose n equal to 0 and theta equal to negative pi over 6. That is not good, not between 0 and 2 pi. Choose 1, negative pi over 6 plus 2 pi, that gives us 11 pi over 12, 11 pi over 6. Right, so negative 1 over 6 plus 2, 11 pi over 6. Which is good, between 0 and 2 pi. Yeah, 11 pi over 6 is like 1.8333 pi. Here's easy. Just use n equal to 0, and we have theta is equal to 7 pi over 6. And that is good. Now, also on this problem, we have 2n pi. So the length over the period is also 1, meaning that we only have one value for n for each case. Right. So this problem is not much different than what we have before. But this one, we have to do the substitution, convert that to a quadratic equation. And so for that, we have 2 solutions for u, 2 solutions for sine, and we do the inverse. That's all we have. Right. So that's what we have for this problem. This one, similarly, we will do the substitution. Here we have cosine. By the way, if this one is sine square, that's perfectly fine. Write the sine square as cosine square. For example, if this problem is instead of this problem, we have 2 cosine, say 2 cosine square minus 3 sine. Let's say if the problem is this, we cannot have sine and cosine square in here like that. But what we can do is we use Pythagorean identity. Cosine square plus sine square is equal to 1. So cosine square here is 1 minus sine square. And multiply it out and solve for that, we should have only quadratic equation in terms of sine theta. Right, need to do that first if it is the case. Well, this is not. We only have cosine here, so that's good. Let u equal to cosine of theta. So in which case, u square is equal to cosine square. And the equation becomes two u square minus 3u plus 1 equal to 0. Right. Look at the graph of that. 2x squared minus 3x plus 1. Right. So look like we need to zoom in. So zoom in, and right, that's better. Right. So look like we have one solution is 1 and the other is 1/2. Of course, if we don't know that, quadratic equation always work. And negative b plus or minus square root of b squared minus 4ac over 2a. Negative 3 plus or minus 3 negative 3 squared minus 4ac over 2 times 2. Be 3 plus or minus 3 squared is 9 minus 8. Square root of 9 minus 8, or just square root of 1 over 4. So equal to 3 plus or minus 1 over 4. The 3 plus 1 over 4, that is 1. And the 3 minus 1 over 4, that is 2 over 4, 1/2. So of course the graph we do see is 1 and 1/2, which is good. So there are two of them. One is 1, the other one is 1/2. So u is equal to 1 and u is equal to cosine. So cosine is equal to 1. So it's easy. Theta equal to cosine inverse of 1 plus 2n pi, or cosine we also have the opposite. To check for the color code. To n pi. Right. Cosine inverse of 1 is still in degree. Cosine inverse of 1, 0. So we have theta equal to 0 plus 2n pi, or negative 0 plus 2n pi. This is silly, right? 0 or minus 0 is still 0. Those two together, we just have theta equal to to n pi. 0 or minus 0 is still 0, so that's all we have. Those two are the same. How many values of n do we have? Well, once again, the length is 2 pi. The period, we have 2n pi, 2n pi. So ignore the n, we have 2 pi. Divide them, 2 pi over 2 pi, we have 1 values for n here. And so we choose n equal to 0. Then we have theta equal to 0. And we say, what happens if we choose n equal to 1? When n equal to 1, the solution is 2 pi. Remember, the solution does not include the 2 pi. It's less than, not equal to. If it has equal to, then yes, we have 2 values for n. But we put the less than, so exactly 1 value for n here. So the evil in the details there. Right? So one solution. Next, we have equal to 1/2. So cosine equal to 1/2. So theta equal to cosine inverse of 1/2 plus 2n pi, or theta equal to cosine has the opposite, cosine inverse negative cosine inverse. Right, what is cosine inverse? Still in degree more. Cosine inverse of 1/2, 60 degrees. So theta equal to 60 degrees, or pi over 3 plus 2n pi, or theta equal to negative pi over 3 plus 2n pi. When n equal to 0, we have theta equal to pi over 3, which is good. Now, on this one, once again, the length is 2 pi, the period is 2 pi, length is 2 pi, the period is 2 pi. 2 pi divided by 2 pi is 1. So we only have 1 value for n that will work. Now for this one, if we choose n equal to 0, it is negative pi over 3, and that doesn't work. It's not between 0 and 2 pi. Now choose n equal to 1. Negative 1 over 3 plus 2. That is between 0 and 2 pi. So we have 5 pi over 3, which is between 0 and 2 pi. So this problem we have 3 solutions. 0, pi over 3, and 5 pi over 3. Yeah. So once again, we just convert this into quadratic equation, and then solve for that first, and each solution corresponding to a trigonometric equation. So we solve both of them. Now, next one, using calculator to express the solution in 2 decimal places. Well, on this one, we can only use the calculator because we cannot solve this by hand. And by we, I mean nobody can solve this by hand. This type of equation, where we have a sine x and an x, a trig function and a polynomial combined. Usually there will be no way to do this by hand. Right, so we use a calculator. I will store this into y1 and then this into y2. In the calculator, and we just find intersection. Remember, before we do anything, let's change to radian, because if the problem did not specify anything, especially in this case, it should be in radian. Okay, we have radian. Right, y1, enter this function 5 sine x, 5 sine x plus x. Y2 is 3. And the intersection is second trace, go down to intersect. If we don't see this, let's zoom out, or standard window is zoom number 6. So I have the graph like that, and equal to 3. Look like there's 3 solutions, 1, 2, and 3. Right, second trace. By the way, if we don't see on the intersection, hit the windows and change the window to appropriate window so we see the intersection. Now we see 3 of them. So second trace, go to intersection. We have the first curve is y1, is that, so yes. And the second curve is 3, yes. And then when we guess, I just move it close to the solution. Hit enter, it will jump right into it. So the first solution is 0.51, 2 decimal places, 0.52. Let's do this again. Second trace, intersection, option number 5. The first curve is this y1, which is good. Second curve 3, good. Now move close to the solution, hit enter, and we have 3.177, 3.18. Do it one more time. Second trace, option number 5. First curve, second curve, and then move close to the solution, and it will jump right to it, 5.71. So that's what we have. Right, like I said, this problem we have to use the calculator because there will be no nice solution. That means we cannot solve this by hand. Right, that's what we have. Right, next we have this type of solution. So what we see is we have cosine and sine. Right, the way we do this is we try to turn this into the one equation, which is either sine or cosine. So the way we do that, let's square both sides. But make sure when we square both sides, we have to go back and check the answer. So we will have square root of 3 cosine of x sine x plus 1. Right. Square the left hand side, we have 3 cosine square of x, which is good. Now the right hand side, we have sine x plus 1 times sine x plus 1. Multiply it out. Sine x times sine x, sine square. Sine times 1 is sine, sine times 1 is sine, so that gives us 2 sine x. And then 1 times 1 is 1. Right, now we did have this problem as mentioned before, right? So if we have both sine and cosine square, trying to turn that into one trig function. So that's why we're trying to square both sides, because when we square it, we can utilize this identity where we can combine the sine square and cosine square. Exactly what we do there. So cosine square plus sine square is equal to 1. So cosine square, subtract the sine square, we have 1 minus sine square. So that gives us 3 1 minus sine square equal to sine square plus 2 sine x plus 1. Multiply it out. 3 minus 3 sine square equal to sine square plus 2 sine plus 1. Yes, move everything to this side. So we have this side 0, 4 sine square plus 2 sine minus 2 equal to 0. Right. Now all of them divisible by 2, all of them are even. So let's just multiply everything by 1/2. And we have 2 sine square plus sine minus 1. Right, so that's good. Right. Now, what we need now is just we have sine square and sine, so we use a substitution to turn this into a quadratic equation. Sine x, so u square equals sine square, and the equation becomes two u square plus u minus 1 equal to 0. Right? I will use quadratic formula. Negative b plus or minus square root of b square minus 4ac over 2a. Negative 1 plus or minus square root of 1 square minus 4 times a times c over 2a. Right, so I have negative 1 plus or minus 1, 4 times 2, 8 minus 1, so 1 plus 8 square root of 9. So negative 1 plus or minus 3 over 4. So negative 1 plus 3 over 4. So that 2 over 4. 2 over 4 is 1/2. And now if we have the minus, that minus 1. So I have two cases, 1/2 and negative 1 for u. Right, there's two cases. U equal to 1/2, u equal to negative 1/2, and negative 1, sorry. Right. And u is equal to what? Sine x. Right? And then sine x equal to -1, and we just go ahead and solve for that. Okay. For this one, we have x equal to sine inverse of 1/2 plus 2n pi, or we have the supplement to it. Sine inverse of 1/2. Yeah. Sine inverse of 1/2. 30 degrees. So x equal to pi over 6 plus 2n pi, or x equal to what? Pi minus that. So we have x equal to pi over 6 plus 2n pi, or x equal to 5 pi over 6 plus 2n pi. Now this one we find all the solution, so we're not gonna choose the values for n, because it is from negative infinity to infinity. The length is infinite, so we're not gonna solve for n. We're gonna keep it like that. However, we still need to check the answer though. Right, now go to this first. Sine is equal to 1/2. So x equal to inverse I don't know why I do that. It's -1. I sub -1 plus 2n pi, or x equal to sine is the supplement. So x equal to sine inverse of -1 -90 degrees, pi over 2 plus 2n pi. Just going to keep it like that. Or pi minus pi over 2 plus 2n pi. So x equal to pi over 2 plus 2n pi, or 1 minus pi over 2, so this is 3 pi over 2 plus 2n pi. However, these two, pi over 2 and 3 pi over 2, pi over 2 and 3 pi over 2, those are the same. I should not say the same, those are coterminal angles. So these two solutions will be the same. We can combine them because they are coterminal angles, so we can choose different value for n so that these two will be the same, right? Both of them corresponding to this point, so only one point on the unit circle. So in that case, I'll just pick one of those. Let's go with this one. This one. And now we check. Because this one we do not restrict the solution between 0 and 2 pi. So we do not choose values for n. We just go ahead and check. The reason we check because we square both sides. Every time we square both sides, we have to check the answer. So first, let's choose x equal to pi over 6. Let's do n pi. For the simplicity, let n equal to 0. And we're just going to check for pi over 6. So square root of 3 cosine of pi over 6 equal to sine of pi over 6 plus 1. Right, cosine pi over 6 is square root of 3 over 2. So we have square root of 3 times square root of 3 over 2. Sine pi over 6 is 1/2 plus 1. As you see, square of 3 times square root of 3 is 3. 3 over 2, 3 over 2. So yes, that's good. So this is a solution. Now check for the 5 pi over 6. Square root of 3 cosine 5 pi over 6 sine, just put into x, sine 5 pi over 6 plus 1. Right, cosine 5 pi over 6. Cosine 5 pi over 6 is negative. Sine of 5 pi over 6 is positive, 1/2. Right? Yeah, 1/2. This side is negative, this side is positive. It's not going to work. So this is a solution. This is not a solution. And then finally we check the 3 pi over 2. Every time we square both sides, we need to check the answer. Right, square of 3 cosine of 3 pi over 2. Is that equal to sine of pi over 2? I mean 3 pi over 2 plus 1. Right, cosine of 3 pi over 2. At this point, cosine is equal to 0. So I have square root of 3 times 0 on the left hand side. On the right hand side, sine of 3 pi over 2. Sine of this point is negative 1. 0 is equal to negative 1 plus 1. So yes. So in this case, we have this two set of solution. That one and this one. This is not. So let's look at this real quick. Let's keep in radian. Now just want to show you real quick. The equation is square root of 3 cosine x equal to sine x plus 1. So first I let x equal to pi over 6. Pi over 6. I will store onto x. Right? That. Now, let's say square root of 3 cosine of x. Now, if we want to test to see if it's equal to second math equal to sine x plus 1, it is equal to 1, meaning that it is true. This is equal when we use second test. It will test the logic values. If it is equal to 0, it will be false. If it is equal to 1, it is true. Now let's choose different value for x, like 5 pi over 6 store into x. And let's test this equation again. It's false. Now how about 3 pi over 2? Again, I'll type the equation again. Square root of 3 cosine of x. Second math, is that equal to sine x plus 1? It can only test, and it's equal to 0, 1. Sorry, I need to store into x first. Then it will be true. Right. So, of course, this is the nice way to check the answer. We have the values stored into x, type the whole equation, hit enter. If it's 1, it's true. If it is 0, it's false. By the way, if this is anything rounding, any rounding error, this will not work. So that's why we have to enter exact values and keep in radian mode. So this is a nice way to check. But like I said, the calculator can only do the estimate. Sometimes one side is 0.9999999, the other side is 1.00001. They say it's not equal to, but because those are the rounding error, they may actually be equal to, but the calculator did not see that. So be careful when you use the calculator to check the answer. That's all I'm saying. Bottom line is, in this equation, when we square both sides, the reason we need to square both sides is to utilize these identities. When we do that, we have a quadratic equation in terms of one variable, sine x. So for that, we have two scenarios. In this case, we do not need to choose how many values for n because we find all the solution. But at the end, we check the answer because we did square both sides. The reason we need to check because -3 is not equal to 3. But when we square it, they will be equal. So we have to check it before we square to see if it is equal or not. And in this case, this is not a solution. So only those two. Right. With that, I stop the video here. As always, thank you for watching and see you in another video in pre-calculus.